10.6, number 15. Supposed to find the area of the region inside the lemniscate. Alright, so we've got an A there. I'm going to square root both sides, so R is the square root of, we can't enter A into the calculator, but I'll enter Y equals, or R equals 2, square root of 2 cosine 2 theta. And then I must have zoomed in once, and that's where I'm at. So the entire thing is not here because my theta step is too big. So if I go to window, my theta step is 0.13. So if I made it like 0.03, try that. If I made it 0.01, it might fill that gap a little bit more, but it would take 3 times as long to graph it, so 0.03 is fine. So you can see that it's like a figure 8 thing. Okay, so we need to know from where to where. So if I hit trace, I'm right here, and I'm tracing. I'm still tracing, my angle is going up, but it doesn't appear until it gets to right here, and so on. Alright, so let's find when R is 0. Back to the original, so 0 equals 2a squared cosine 2a. So all that is a constant, so it doesn't matter. So when is cosine 0? Cosine is 0 at pi over 2. So theta is pi over 4. So pi over 4 is right here. The next time cosine is 0 is at 3 pi over 2. So 3 pi over 2 equals 2 theta. So theta equals 3 pi over 4, which is right here. If we integrate it from pi over 4 to 3 pi over 4, that's not going to give us one of the petals or half of it. So let's figure out where this is, which is when is cosine 0? It's also 0 at negative pi over 2. So negative pi over 2 equals 2 theta. So theta equals negative pi over 4. So we're going to go from negative pi over 4 to pi over 4, and that'll get us that whole area, and then we can double it. If you notice what happens if we went from pi over 4 to 3 pi over 4, when I was tracing it, so 0, you can see it's tracing, and then it just disappears. I'm still tracing until it gets to 3 pi over 4 right now, and then it goes from there. So it doesn't even appear on the axes. Curious what would happen if I used my calculator and integrated it from pi over 4 to 3 pi over 4, and it gives us a negative answer, negative 2. So it's the same magnitude, I think we'll find, of this, but it's a negative. So we can explore that more some other time. So back to this problem, we're going to integrate 1/2 r squared d theta from negative pi over 4 to pi over 4. And I might as well, does it say to do the whole thing? What number is this, 15? Inside the whole thing. So I'm going to double it, and that'll give us both of them. And our r squared is just 2a squared cosine 2 theta. Alright, so pulling out the constants and the a squared, it looks like I'll have a 2a squared on the outside, and cosine 2 theta on the inside. Antiderivative of that is 1/2 sine of 2 theta. Still have 2a squared here. So really it's just a squared sine of 2 theta from negative pi over 4 to pi over 4. So a squared sine of 2 pi over 4, so pi over 2 is just 1. And a squared sine of negative pi, that's negative 1. So I have an a squared plus a squared gives us 2a squared for the area of the lemmascape.